So we've been working on converting standard form to vertex form, but we've been focusing on our perfect squares. So today we're going to look at what happens if we don't have a perfect square. Just to refresh your memory, standard form looks like this. And when we talk about standard form, what we're looking at is kind of what is inside of our box, or what is the tiles representing in this diagram. Okay, it's kind of the area that we get when we multiply this out. So the blue square that we have here would be x times x. That's going to give me an answer of x squared. Each of these green rectangles represents an x. So I have 3 x's here and 3 x's here, which would give me a total of 6 x's. And then each one of these yellow squares represents a unit. So I have 3 units by 3 units, which would give me a total of 9 units. And that's my standard form. My vertex form is going to be looking at what's around the outside of our box. So we're looking at our length times our width. Our vertex form looks like this, and it actually, if you remember, has an a value in front. For all of the problems that we're looking at, our a value right now is 1, so we're not going to include that in our vertex form. And also, because we're talking about a perfect square, we don't need this plus k on the end. We're just looking at the part that makes a square, which is just that x minus h squared. So again, if you look down here, we're just focusing on our length and our width here. So if I were going to write this in vertex form, I would have x plus 3 squared. Okay, so that's what we get if we have a perfect square. If we don't have a perfect square, we need to kind of make an adjustment. So here I have set up a diagram and a box method, and I'm going to show you both ways of looking at this standard form. So in my diagram, I have my x squared, I have my 6x, which again is going to leave me 3 x's on the top and 3 down the side. But this time I have 12 unit pieces. What I want you to notice is this is what gives me a perfect square, 9 units. I also have this extra. That extra needs to be included when we do our vertex form. In our standard form, we have it. It's this 12 right here. But in our vertex form, I can't just write x plus 3 squared, okay? Because x plus 3 squared would only be what I get in a perfect square. So here's what I do, okay? I'm going to start off the same way. I've got my x squared, I've got my 6x, and I've got, in a perfect square, 9 units. Those 9 units are these 9 that I have right here. Okay, that's what I have. But then I have to think about, okay, I have 9, but what I really want in my problem is 12. So what I need to do is figure out what do I need to do to go from the 9 that I have to the 12 that I want. And what I have to do is I have to add these 3. So if I have these 9 plus these 3 over here, that will give me my 12. Well, in my vertex form, I just need to add those extra 3 to the end of it. Let's look at another problem here. Okay, again, we're going to set it up. We've got x plus 2. I know how to set up my box and my diagram because I'm going to look at this part of my problem. Okay, and I'm going to think about, okay, what would I need to do to get a perfect square? So I'd have my x times x, my x squared. I would have my 4x, which I would split up 2x and 2x. So I have x plus 2. Then I only have 1 unit. Okay, again, not a perfect square. I hope you can see that. Perfect square would fill this whole thing in, so I'm definitely missing some parts here. All right, let's look at my vertex form then. Okay, so I've got my x squared, I've got my 4x. What I have, now remember, everything is based on if it was a perfect square. If this was a perfect square, I would have 4 ones. Okay, because remember, vertex form starts out, what would it be if it was a perfect square? In a perfect square, I'd have x plus 2 squared. But I have in my perfect square 4. What I actually want in the problem is 1. Okay? Remember, if you look up to your standard form, I don't want 4 units. I only want 1 unit. So what do I need to do to go from the 4 that I have to the 1 that I want? Well, what I need to do is subtract 3. So in my vertex form, I'm going to have this, which represents my perfect square, but then I'm also going to subtract 3. So before we stop, just take a minute and think about what does this adding or subtracting value that we're doing on the end represent. Remember, in our vertex form, this is our plus k. This plus 3 that we have here, or this minus 3, that's the k value in our vertex form. And what I want you to see is that vertex form, that k value, represents the number of units that you either need to add or subtract to go from the perfect square that you have to the number of units you actually want in your standard form. So remember, vertex form is based on a perfect square, and then you just have to modify it and figure out what you need to add or subtract to get what you really want instead of the perfect square.